right, welcome to YWR, everyone. We're doing something really interesting today. We're going to look at a very exciting biotech company with tremendous upside. And because I don't know very much or anything about biotech companies, we've invited an expert, John Kulak, who I met at an investment conference, and we're going to do this in two parts, a little bit different today. We're going to start with John's going to give us the setup, the background, the work he's done on the idea, and kind of explain a lot about it. So we'll get a good understanding of Inmune Bio, the company, and then we're going to talk to the CEO and do some follow-up questions. And so we'll be able to ask the CEO some stuff. But just as some the backstory, the background, John, we met at an investment conference in Madeira, Portugal. And I have to say, and I loved, we met right at the beginning, and it was really good chatting with you. And you actually presented an idea about the auto industry at the conference and about how the business model is changing and how it's moving more to data and software. And if auto companies don't adapt to this, they're going to be in trouble. And that was super interesting. But then everyone was sending around this write-up you did on Inmune Bio, which we're going to discuss today. And so I was like, oh, look at this. Have you seen John's write-up on this? And I was reading it and I thought, oh, wow, that sounds amazing. That sounds like insane upside if this works. But it's not my field of expertise. I think how a lot of people feel biotech's not something a lot of people are comfortable with. But you made it very understandable. And so I just wanted to pass it over to you and say, well, thanks very much for coming to YWR and sharing this incredible idea with us.
Okay, so the origin story of Inmune Bio for me was actually during the start of COVID. Me and a couple of buddies were looking at what biotech companies could potentially benefit from a drug they might have for, to help with COVID or long COVID or some of the symptoms. And Inmune Bio, it came up on that screen. I didn't love the idea for COVID. But what I did like, and I put it aside and then did a lot of work on it a couple of weeks later, was their program on Alzheimer's, and more specifically also their drug XPro, which they were using as a potential therapy for things like for CNS indications like Alzheimer's. And what first got me excited was what you see here on the at the bottom of the slide here was a metadata analysis that took a look at 8.5 million records, health records. And what it found that is if you had rheumatoid arthritis, you were 8 times more likely than the general population to one day get an Alzheimer's diagnosis. However, if you had rheumatoid arthritis and you were on what are known as anti-TNF drugs, things like Enbrel and Humira and Remicade, which are huge drugs and I think 40 billion in sales last year, you were 60% less likely than the general population to get Alzheimer's. These are drugs that are currently used for autoimmune diseases like, again, rheumatoid arthritis, ankylosing spondylitis, a lot of drugs, a lot of indications like that. So you take a look at this and you're like, wow, there's clearly something going on here that suggests that a lot of the popular thinking around Alzheimer's might be wrong, and that targeting inflammation, the inflammatory response, might be a better approach than what's out there today. And these numbers, again, given the number of health records I looked at, given the strong correlation here, it was definitely worth a further look, which is what I did. Okay. So what makes XPro, first of all, different? Because one of the questions I get is, okay, John, you see this, and why not just use something like Enbrel or Humira for things like Alzheimer's? Well, it turns out that there are two different types of TNF blockers, or TNFs. There's the soluble TNF, which is basically, the way to think about it is the bad TNF. This is known to cause acute and chronic inflammation and cell death. And then there's transmembrane TNF. this improves the immune response, is neuroprotective. This is what you need when your body sort of is responding to a cold or an infection or what have you. This is the stuff that helps protect you. And what Immune Bio does that's different is they keep the good and knock out the bad, whereas the first generation anti-TNFs knock out both. And that matters for a number of reasons. Most importantly, because Alzheimer's is frankly a disease of the elderly, many times, ATNFs are not appropriate because they have other issues that make them sort of not be good candidates, because the anti-TNFs can cause a whole number of um, bad side effects, including higher rates of infection, higher rates of cancer, and what have you. So the good TNF is what you want to keep. The bad TNF is what you don't want to keep. And again, XPro is much better. It's the only one that actually does this. The other thing, which this slide doesn't talk about, but they've now learned after doing further tests, is that the XPro and the good TNF does a much better job of going through the blood-brain barrier than the old ones that have a much harder time of doing that, because both TNFs just can't get through the blood-brain barrier like XPro can. So what Immune Bio's Alzheimer's program is sort of simplified is they believe that neuroinflammation is a cause of Alzheimer's. Soluble TNF causes neuroinflammation, and XPro neutralizes soluble TNF to reduce neuroinflammation. And so they did. So this is their theory, and they went ahead and did a small test. And what they found was amazing, even though it was a small n size. What they found was that if you give these, these participants XPro, again, it was a small number. Two of the 11 in the test actually showed meaningful improvement in their symptoms. One minor improvement. You had 5 who were stable, who didn't improve or decline, and you only had 1 with minor progression. This is frankly unheard of in the Alzheimer's world. Now, the current drugs that are trying to get approved right now, like Lilly's drug, what they are saying is they are claiming that 35% less progression is enough to get something approved. And the early results for XPro were that not only were they able to stop the disease from progressing, but there were actually people in the trial who improved, who in fact got better. And what also made me confident that there was really something there was the patients with the greatest improvement in cognition also had the largest reduction in neuroinflammation. Okay, which again supports the notion that INMB is targeting the right thing when it comes to Alzheimer's, and that again, the greater the neuroinflammation, the better the result.
And
The better
John,
the
wasn't there
results.
one story of the principal, or are you gonna the
Yeah,
guy?
I'm
There
going to
was
get to that
what?
right now. So
Oh, okay. Well, I'm jumping in.
yes, yeah. This is a look of remodeling of the white matter tracks after XPro. You can see from the baseline there's tons of tangles. The brain was not functioning well, and after 9 months, which you see in the green and blue, it shows improved axonal quality. But what really another thing got me excited, and I have um, a short audio clip of the principal investigator. She talked about the remarkable improvement in these patients' lives.
The other gentleman I'd like to present, let's call him Bob. He's a retired deputy principal of a high school, and he's got a background in pharmacy and science, and he's a teacher of physics. He came to us on the milder end of the Alzheimer's spectrum, having stopped work 5 years ago when he noticed that he was starting to forget the formulae that he needed to teach his students. Since being on his trial, he's telling us now, I've gone back to my usual life. He feels energized, motivated, and his concentration and memory have improved. He's now able to recall physics formulae and far more. And he's even taken on a few students to tutor during this COVID time. He's gone back to reading academic journals, and he finds that he's not only able to understand the information that he's reading, and as for all of you who read academic journals, you'll recognize this is no easy feat. but he's also able to recall that information later. He's even started writing a book, which he had been considering for a number of years beforehand, but hadn't had the motivation or courage to start. So as you can see, for both of these participants, there's been a meaningful functional improvement that's occurred in quite a short period of time. So that's been super exciting to be a part of.
So again, you go from cognitive decline to writing a book in a 9-month period.
I think that story is
If
amazing.
that doesn't get you, yeah,
Yeah.
that doesn't get you excited about the story. Frankly, nothing will. The what I often
The other
get,
gentleman that
what I sometimes frankly get with this story, where people get a little bit nervous, is it sounds too good to be true. So um, I'm just not going to invest in it for that very reason. And I actually think that heuristic works quite well if you're a professional investor. A good deal of skepticism, I think is necessary in order to make money in this world. But occasionally, things that sound great are in fact great. And I think a good example of that, frankly, are GLP-1s, which I know there was a lot of skepticism that could these drugs really solve the obesity problem? In the US and around the globe. And a lot of people initially were skeptical. And it turns out that, yes, they can. And not only can they, that, these drugs are relatively safe and have been around for 25 years. And they've just undergone massive improvements by companies like Lilly and a few others, like Novo. So anyway, I think that there's a really good chance it's going to work. I know we're going to have the CEO on a little bit, and I want him to talk more about what's going on today in phase 2 and why this is so exciting. But this program is so exciting and so exciting for CNS. But what has me, sort of, this is not enough of a blue sky as far as the opportunity. It's that, 50% of all deaths right now can be attributed to inflammation-related diseases. That comes from everything from neurodegenerative, psychiatric, autoimmune, cancer, cardiovascular. So there's a world in which this drug, which is an incredibly safe drug, as opposed to all the other TNFs, could play a role in a number of diseases. So the CNF indication is already pretty massive, but moving further on past that, there's a world in which these can be, I know this sounds ridiculous, just as big as the GLP-1s. They really could, if the data holds true. So you're really talking here about a company that's roughly around $150 million market cap. You can see what some of the other companies, how their market cap improved based on quote unquote successful phase 2 data in Alzheimer's. And InmuneBio is sitting there at $150 million. Share price is around $5. I think this can easily get to, a $2 billion market cap on successful phase 2, which is a massive improvement. And if they hit it out of the park in phase 3, I mean, you're talking about a really rare opportunity that doesn't come along very often. Will this work? I mean, to me, everything stacks up like it will, but it's a small cap biotech. All the necessary precautions should be in place. You need to size this appropriately. I think everybody who's listening to that understands those rules. But the upside versus the downside here is just massive to the upside, and it has me really excited. It's a bigger position than normal for me. It's certainly not my biggest, because again, this is still at the science experiment stage. But right now, all the data is lining up that this is going to work, and there's nothing that they've done or shown to suggest anything to the contrary. Again, which has me super excited. And again, this is not, in my view, I'm going to stop sharing the screen. This is not just an opportunity in Alzheimer's, which is frankly big enough. It is an opportunity, I think, across Parkinson's, MS, a whole number of CNS indications, and then further on down the line, autoimmune, and a whole bunch of other diseases. So it's a massive opportunity. You don't even need to hit those in order for this to be, a 20 to a 50 bagger. So,
Yeah.
and I know I'm a little out there in saying those things, but
No,
I
it's
make these cases, and they are like, yeah, if it works, you're right.
yes. And the timing is so the stage two is probably sometime mid 2025, right? I mean, it's not that far away.
They're guiding towards May. They're guiding
Yeah.
towards May. I think that's right. But
Who
um,
knows? It could slip. And
to the extent that there's been problems with the company, it's missing deadlines.
yeah,
Frankly, they've missed
yeah.
some deadlines. There are some that were their fault. Some I think were things outside their control. But if you just want to say mid next year, that's a little bit safer. But again, enrollment's closed in the phase two, so it should be 6 months. It should not be much more than that.
Okay, so um, very promising stage one data. Um, Stage two just around the corner for the results. The metadata, the background, the correlations between inflammation and Alzheimer's already kind of backing it up. So yeah, it looks everyone's understands that this is as with biotechs, this is these risks that if the data isn't good, it'll be a real struggle and probably a lot of downside. But as you said, the risk reward is that multiple X's of upside likely if this is encouraging, and not only the first use case, but we might find we use these types of drugs for lots of other things as well. And they actually also I mean, yeah, we always want to make money, but it would be really positive as well if there were these, solutions. It would be like this story. I mean, the story of the physics teacher, for example.
Yeah, and so it's really it's a terrific opportunity. It's again, as I said, um, I've spent time trying to poke holes in this, and it's a struggle to poke holes in the science. You can poke holes in how maybe they've done things, and there's certainly some frustration with this has probably taken 2 years longer than it should have. But the science is the science,
Yeah.
and I think it's going to work. But again, caveat
Okay.
emptor as they say.
Well, John, thanks very much. I think we're all, experienced investors and understand, and yeah, I think everyone appreciates the risk. But thank you for, I mean, that what's so helpful is thanks for teeing up the background on the drug and the science and getting us prepared. And let's now we'll hop over and ask the CEO some questions. But thanks for getting us prepared. All right, everybody, welcome back to YWR. We just heard from John about Inmune Bio and learned about water-soluble TNFs. But now we have a special treat. We have the CEO, RJ Tesi, on YWR, and we can dig further into this tremendous idea and the upside. And I apologize, I may not have pronounced your last name correctly, but RJ, welcome
Tesi,
to YWR.
Tesi.
Tesi, okay,
Yeah,
excellent.
yeah,
Um,
yeah. Eric, thank you very much. Great to be here.
you're based in Florida, right?
So the company is based in Florida. We're based
Oh,
in South Florida, although it was founded in Southern California.
oh, okay.
But we're a small company. We only have 22 people, and as typical of a clinical stage biotech, we have 22 people, and I think 15 of them are in different zip codes. So we're
Okay.
scattered around. So,
Well, hopefully you're in someplace warm and nice.
yeah,
But
absolutely,
um,
absolutely. So.
so I think we'll get into the company and the what you're working on. But I always find it interesting. This is Immune Bio is not a kind of VC inspired company. It's very tightly owned by the management team, and I just wondered if you could talk a little bit about how you came into this and how you decided to found this company, and maybe what path brought you into this area of the biotech world, and yeah, just kind of the backstory of how you got here.
Yeah, thanks. So I was a transplant surgeon, an academic transplant surgeon in my past, and what transplant surgeons are all about immunology. We have to conquer the immune system to allow people to accept these new organs. So I was really a clinical immunologist who got burned out because I was working 24/7 and joined industry first with a little company called Sangstat Corporation, which was the transplant company. And basically, over the 20 years of my biotech career, inflammation and immunology has become increasingly important. So I was well positioned, but quite frankly, everybody was focused on autoimmunity and everybody was focused on cancer. And then suddenly XPro dropped in my lap, and it came through a very unusual path. And here I am sitting, I've always been a guy who doesn't like doing Me Too stuff. I kind of enjoy doing the cutting edge stuff. I guess I'm a glutton for punishment because not only is it the highest risk, but it is the highest reward. There's no question about it. And I mean intellectual, clinical award. At the end of the day, I'm a doc, right? It's all about making a difference at the bedside. And to me, the great frontier is CNS drugs. And I think the CNS space is now kind of where oncology was 15 years ago. We now have biomarker tools, we have imaging tools. We can really begin to start to make a difference in these diseases. Whereas oncology is kind of, innovation is flattening out. CNS, we're just hitting the steep part of the curve.
RJ, what is
It's gonna be a
CNS?
hell of a
I
run over
apologize. I don't want to get too, but what is CNS? I think we own oncology drugs, but this space we don't know as well.
CNS is the central nervous system. It's the term of art we use, and it's really the brain. When we talk about the nervous system, there's the brain and the peripheral. What's happening in the legs. When we talk CNS drugs, we're really talking about those things above the eyebrows, right? And that is a big black box that is still a black box, but it's not quite as
This is
dark
the
as
Wild
it
West,
used to be.
right? You're saying.
We are at the beginning of really a very exciting time. Yes. Yeah.
And so you've been drawn to this, and you think this is where some of the really interesting breakthroughs are going to be happening in the space, in this CNS drug space.
And then what happened was that when you sit there and look at all of these diseases, and let's talk about Alzheimer's because we're an Alzheimer's company. People were looking at Alzheimer's and they go, there are these ugly things called amyloid plaques and called tau tangles in the brain, and they cause inflammation. So they said, okay, we have to get rid of the cause of the inflammation. Let's make drugs that go against amyloid or tau. But then over the next decade or so, people began to kind of wonder, I wonder if it's the other way around. If the original sin is actually the inflammation, let's call it neuroinflammation, because we're talking about the brain, we're talking about the CNS. Is the original sin really neuroinflammation? And that begins this cascade, this doom loop, where inflammation causes amyloid, which causes more inflammation. And, we took a hard look at this. And if you look at the brains of people that die, only half of the people with amyloid in their brain have Alzheimer's. So that means the other half are doing just fine. So amyloid, I don't know. But 100% of the people that have inflammation in their brain have Alzheimer's. So to us, we said, let's flip this around and let's go after inflammation. And it turns out we have a drug that does that extremely well, probably best, we think it's best in class. Let's go after inflammation because that's where the problem starts. Now, you can imagine, I've been working with this drug since 2011, so that's now more than a decade. And when I first started wandering around talking to investors, let's call it 2013 and 2014, and I came to them and said, I have a drug to treat Alzheimer's disease, and it targets inflammation. They looked at me like I was absolutely nuts, because the groupthink of the time was that if you're not targeting amyloid or you're not targeting tau, you don't know what you're doing. So we've been a voice in the wilderness. Quite honestly, VCs wouldn't have anything to do with us. So we were brave enough, foolish enough, I don't know how you look at it. We said, okay, well, if they don't want to work with us, we'll do it on our own. So we did a, quote, friends and family round and clawed our way onto NASDAQ, and then have been raising money on the capital markets since. So that's the origin story. So
maybe it might end up one of those blessings in disguise where you end up having more control of the company, and also maybe we're able to maybe stick with the path longer because it's been a long journey, and a VC might have try to course correct you into something else and trying to find some other commercial thing to do, but it maybe just takes.
No, you're absolutely right. So one of the founders, David Moss, who's our very talented CFO, was a VC in his previous life, right? So in fact, he has some strong beliefs about the venture capital ecosystem, and he is very pleased that we in fact have the structure we have, where management participates just about in every round that we raise, and we own certainly in excess of 25% of the company. So there's no way we would have that kind of ownership stake.
Yeah.
And it's not about the money, it's about control, strategy, direction, right? That's what allows us to do, right?
And it's, I mean, you're 9 years into this, so it's taken some persistence to get to where you are.
It takes a while. I always used to say it takes 8 years for a biotech to be successful. Well, I guess we're going to be a few more.
So RJ, I think it all sounds, it sounds like it makes sense, and it seems like there's tremendous this upside, and it sounds great. But then I think all the skeptics out there, the natural question will be, why is this falling? Falling into your lap is not. You definitely say nothing's fallen into my lap after what I've been through the 9 years. But like, why is this being neglected? Why is Genentech not doing this? Or why are some big names? Why is this kind of opportunity there for Inmune Bio to work on and to capitalize on?
Yeah, so that's a great question. I'm going to attack it really in two ways. First, I'm going to say kind of where the mindset of big biopharma is, and then really why we're so confident that this was the path to follow. So the mindset of big biopharma is risk reduction, right? They have peak profit and loss responsibilities. They don't want to stick their necks out, because if someone sticks their neck out, they lose their job, right? So they tend to follow the leader, and the leader, because that's what the NIH said, that's what the academics said, that's what the thought leader said, was amyloid and tau. Okay, so that's where the drug development and research was focused, and that's what they do. Look at the people that are in the amyloid tau business. It's Biogen, it's Eisai, it's Lilly, who's in tau, Roche, and Roche was until 2 days ago, and some others. So in fact, Big Bio was following the accepted biomarkers. Now, interestingly or paradoxically, the fact that now those drugs are, shall we say, mature, those targets are mature. We've got 3 anti-amyloid drugs approved. Clinically they're unsatisfactory or less than satisfactory. And as I said, Roche just walked away from tau because it doesn't work. So in fact, the space suddenly looks a little different. It's getting a little smaller, right? And so people are looking around and say, what else is out there? And it turns out third up is inflammation. And we believe we have the class of the field. Now, I already told you one of the reasons why we think inflammation is important, because the people who die with Alzheimer's disease have inflammation in their brain. So that's number one. Number two, when you look at the animal models recapitulate Alzheimer's disease pretty well, and it's all related to neuroinflammation. And if you get rid of that neuroinflammation with a drug like XPro, you get rid of the disease. Now, why are we so confident XPro is the right drug? Because XPro goes after soluble TNF, as you said. Well, because soluble TNF is really the match that lights the fire. And what do I mean by that? As a clinician, I always say, okay, here's this great idea in mice, right? One thing I've learned is you got to be skeptical what happens in mice, because first of all, they have 4 legs compared to people that have 2. But the point is, the animal studies give you insight, but they don't give you, shall we say, confidence until you can somehow connect the dots in man. And where we connected the dots in man was really quite obvious. It turns out there's a human model, to put it crudely, of elevated levels of TNF that cause Alzheimer's disease. And that's women with rheumatoid arthritis. Rheumatoid arthritis is a debilitating arthritic disease. It's basically been cured by the anti-TNF drugs, right? But this is 20 years ago. That's what really changed the lives of these women with rheumatoid arthritis. So we have 20 years of data to look at these women. And when you look at them, you say, wow, this is pretty interesting. If you had rheumatoid arthritis and you had that untreated elevated soluble TNF in your blood, you have an 8-fold increased risk of Alzheimer's compared to you and me. 8 times the risk. Unless you get treated with a TNF inhibitor. If you get treated with a TNF inhibitor, your risk plummets to less than 50% of the risk. So clearly soluble TNF is doing something bad in those patients.
So it goes to
and
below
if you get rid
average
of it,
instances of Alzheimer's.
you go to
below
less
a normal. Yes.
Now the important point here is it's not just getting rid of inflammation. So if you use some other strategy to treat that rheumatoid arthritis, they still have that high risk of Alzheimer's. So the bad actor here is soluble TNF. So that's the first important point.
RJ, let me just follow up here, because when we talk to people about this occasionally, you stop here and they go, well, why not just use Enbrel? Why not use Humira? And I think this is an important pivot for people to understand that it's not, I'll let you take it from here, but that's a question I always get at this point of the discussion when I talk to investors.
So that's the second leg of the stool. It's safety. First and foremost, when you're treating a bunch of Alzheimer's patients, it's got to be a safe drug. These aren't Olympic athletes. If you look at our clinical trial, the average age is 73, but we have patients that are like 85 and 88 in the trial. I mean, these guys, they're fragile, right? Now, the reason you can't use the current drugs that are approved and very effective at treating autoimmune disease is because of the safety profile. And what do I mean by that? It turns out, and this, I guess you and John talked about this a little bit, that there are 2 TNF cytokines. There's the bad actor, that's the soluble TNF. That's what you want to get rid of. But there's a kissing cousin that's called the transmembrane TNF that is the good one. So you have like the bad actor and the good actor. The good actor does 2 things. It prevents the immune system from getting weak and making the patient susceptible to infection. And it also promotes remyelination. Now, so let's unpack that a little bit. The average elderly patient, because it comes with age, already has a somewhat dampened immune system. So you can't give them a drug that pushes their immune system down even more because you're going to make them sick. The current drugs do that. Our drug doesn't do that. In fact, it makes the immune system stronger because of this specificity. The second thing is patients with Alzheimer's disease already have demyelination. Myelin is the insulation that's around the nerve cells that keeps them from shorting out. And that myelin sheath starts to disappear, and that's a complicated, interesting story, but it's common. People think of it's common in patients with Alzheimer's. If you give them the currently available TNF inhibitors, the demyelination gets worse. So they actually get sicker. Our drug actually promotes remyelination. So even though we have a TNF inhibitor and the other guys have a TNF inhibitor, it's all a matter about what the target is. Ours is a very precise rifle shot at TNF that only takes out soluble TNF. Theirs is a shotgun that takes out both soluble and transmembrane TNF. And that's why we focus on diseases of the brain, the CNS. And we don't have to worry about those guys playing in our sandbox, right? But it's also the reason we didn't go after rheumatoid arthritis, because we would have been like the 15th drug for rheumatoid arthritis. But we're going to be the first to target neuroinflammation and make a difference in Alzheimer's disease.
Well, it sounds good. Going back, and I'm just thinking, so it's 2 things. I mean, one was the industry doesn't like to take risk, and 2,
Absolutely.
There's been this road everyone else went down about the plaque, and they were following, and you're saying that road is actually starting to the amyloids, that's starting to actually turn out to not be the road. Some of the studies and test results there are coming in negatively.
Just look at the results. What do you get when you get an anti-amyloid drug? You get slowed progression. In other words, you don't get stabilization. That's kind of what people want. They want the disease to stop. you get slowed progression. You get between 4 and 6 months more being able to button your shirt. Now, that's a crude way to say it, but that's an advantage, but it's not. People are looking for more. That's number one. Two, you get a safety risk. The safety risk is real. And I mean, all you have to do is look at the data. Some patients have died, but these are old patients. People die. I don't want to tar and feather these drugs because, they have started the revolution. But the bottom line is there is a risk, and the publications and the regulatory community is clear. The UK, Europe, Australia all have refused to approve these drugs, right?
Yeah.
Because the value proposition, and when they talk about the value proposition, they think the benefits based with the risk and the costs don't add up. So right now they're waiting. So in the US, you can get an anti-amyloid drug. You can't in the UK, you can't in Australia, you can't in the EU. And you won't be able to in the near future. So, so safety is very, very important. One thing about XPro, it's as safe as chips, man. I mean, it is really safe. The only thing you get is some patients get kind of an angry mosquito bite where the drug is injected. It's a once a week subcutaneous injection, like an insulin shot, like one of the anti-obesity drugs, like Ozempic, right? The patient can give it themselves, or the caregiver can give it to the patient. They don't have to go to the physician. They don't need all these MRIs and CTs and all that stuff. It's a very friendly drug for the patients. And when you've got a patient with dementia, getting them in the car and dragging them off to a clinic is not as easy as you and I going down to the local 7-Eleven, right?
No.
So anyway, so you're exactly right. The pathway is getting clearer. Before, where we always had to jump over amyloid and jump over tau to get people's attention. Now everybody goes, well, we know what they do. Let's look somewhere else. And as people start to look somewhere else, here we are, right?
Yeah. And no, that's very that's probably been a long road of, and I hope there's a big I told you so at the end of it.
Oh, believe me, I can't wait to say I told you so. I can't wait.
Let me ask you, RJ, because it's I think we have a really good sense of up to the point of the beginning of phase 2, right? And one of the other things that when I talk to people, what they get excited about is both the design of the trial, but then also there have been some breadcrumbs along the way that we've seen, whether it's taking a look at further brain imaging or some of the data that you've seen to suggest that you guys are really on the right track, that the deck is kind of stacked. So if you could talk through some of that stuff, that'd be great.
Yeah. So one of the things that investors frequently misunderstand is that part of the clinical trial process is de-risking your phase 3, right? The phase 3 is the big kahuna. That's one where you got to hit that home run. But you can't expect to know all the answers immediately. So as John said, we did a phase 1 that was quite unusual. It was unusual in 3 reasons. First of all, we were targeting neuroinflammation, right? Because that's what our drug does. So we wanted to see, with people with Alzheimer's disease that have neuroinflammation, does giving them a drug that gets rid of neuroinflammation make a difference? So we weren't looking at cognition, although I'll talk about that in a second. We were looking to see do we get rid of neuroinflammation? So the first question is, how do we tell who has neuroinflammation? Because there's no disease on the planet where 100% of the people have, quote, the same pathology, right? So we said, okay, we dug around and we made some educated decisions about who to enroll. We did what's called a biomarker-directed enrollment strategy. And this is what they do in oncology every day. I mean, in oncology, they don't enroll every patient with breast cancer. They enroll a segment of people that have a pathology that matches the mechanism of the drug. So we only enrolled patients with dementia that had biomarkers of inflammation, and these were very easily to measure. Just a simple blood test, really, that can be done by any lab, and there were 4 of them. And if you had one of the 4, you enrolled in the trial. Now, the trial was done in Australia, so about 40% of Australians, they're all Caucasians for all practical purposes, were met the criteria. So the number one difference was we were looking for a select population, not everybody, but the patients who were what we call hot, ADI, Alzheimer's disease with inflammation. Okay, so that was number one. When we looked at the biomarkers of inflammation in the CSF, in the blood, and in the brain with neuroimaging, bingo, they all went down exactly as we predicted, exactly as the animal studies were predicted. But even I, as a clinician, I'm going, oh, well, that's pretty nifty. I mean, neuroinflammation goes down, but neuroinflammation is not the underlying pathology of Alzheimer's disease. What's the underlying disability? The underlying disability is nerve cell death, i.e., you lose the memories, and something called synaptic dysfunction, the ability of the cells to communicate. So ultimately, to become demented, to have cognitive decline, you have to have synaptic dysfunction and you lose nerve cells. So we got rid of neuroinflammation, but for me to now go invest a ton of money on a phase 2 trial, I wanted a little bit more. So we looked at the downstream effects of getting rid of neuroinflammation. And lo and behold, you had increased nerve cell survival, less neurodegeneration. You had improved synaptic function, both by looking at it biochemically and looking at brain waves on the EEG. And you had increased remyelination, as I had already stated. So clearly, all those things happened. Now, so we got excited. And then, quite frankly, we couldn't help ourselves. Even though this trial was not designed to look at cognition, everybody asked, we wanted to know. It wasn't powered appropriately. There was no control group, but we still kind of took a peek under the hood. And we had an independent blinded neuro cognition expert look at these patients. And of the 9 patients that could be evaluated, 8 of the 9 in a 3-month period remained stable or got better. I haven't heard any other company talk about patients who got better. 1 got worse. So we're 8 for 9. That's pretty damn good. Now, do I expect to have that same ratio in the phase 2? Probably not. But I do expect some patients to get better, because one of the fastest things that happens when you get rid of neuroinflammation is those synapses hook up again. So you haven't if the nerve cell hasn't died, if your mother's birthday, you can't remember it, but that nerve cell is still there. It's just disconnected from the network. When that synapse hooks up again, boom, you remember your mother's birthday. And that happens in less than 3 months. But anyway, I'm getting ahead of myself. So we thought we had a great outcome from our phase 1. We learned a lot, and we took those learnings and we designed the phase 2. We didn't change a lot. We had the biomarkers. We designed a trial that would get us the answer as efficiently as possible. And the things that people get, shall we say, are unique about our phase 2 is it's small, 200 patients. It's short, 6 months. And we use a sensitive cognitive endpoint called EMAC. Now, why are we doing all these things? Well, first of all, raising capital in the last 4 years has been hard, full stop, right? So we had to be efficient, right? But also, there's no reason to spend money just because you can. The real money you want to spend is on the registration trial, which is the phase 3. So because we select patients for neuroinflammation, we know they get worse fast. Their cognition declines rapidly, and I hate to say it, but reliably, which is the statistical term would be variance. And we know that our patients are going to have a more or less a stable response. In other words, we're flatlining the patients. In other words, the day they start XPro is the day their cognition stops getting worse. And with that modeling, it allows us to do a 6-month trial of 200 patients with a 2-to-1 randomization. Once again, we're using the enrollment. Now, the final thing is EMAC, the cognitive endpoint. We're using a cognitive endpoint that is better than the other stuff out there. It's more sensitive, and some people get excited because they say, well, if it's more sensitive, you don't know if it's really good. And we say, no, we know it's really good. It allows us to do an efficient, fast clinical trial. But no matter what the results, when we go talk to the FDA for the end of phase 2, we will agree on the proper cognitive endpoint. We hope to convince them it's this thing called EMAC versus CDR, which really isn't that good. But it's their sandbox. We'll play in it no matter what. The bottom line is what we have promised investors, what investors and potential partners are looking for is, do we make a difference in cognition in phase 2? And we will be able to answer that question unequivocally at the end of this trial.
And RJ, it's just timing wise, it's about mid 2025 the trial wraps up.
Yep.
Or?
Yep. We're kind of in that time now where the patients are kind of ripening. I guess that's what you say. They're on the drug or they're on placebo, and until that last patient hits their 6-month anniversary of treatment, then we go through a process where the database is cleaned and locked, and then we'll announce top line data. And what people want to know is what happens with cognition. As I said, the safety is not going to be an issue here. I mean, the safety, it's safe as chips. So, we're going to live and die on efficacy. And as John mentioned earlier, when you look at the pathology, i.e. people die with neuroinflammation, have Alzheimer's. When you look at the animal studies, then you look at the results of the clinical experiment with rheumatoid arthritis. Then you look at the results of the phase 1, and you look at how we chose to design the phase 2. When you stack all those up, each one is a de-risking strategy that we think we're in a pretty comfortable place. What's funny, I wake up a lot at night worried about stuff, right? I rarely wake up at night worried about our clinical trial design or whether our drug's going to work. There's a bunch of other little problems out there. Well, big problems. But we know how the drug works. We know how it aligns with the disease and the subset of patients. It's only half of the patients with Alzheimer's, but I'll take a market of 9 million patients. Thank you very much, right?
Yeah.
When you look at both mild AD and MCI, maybe it's not quite 9, but it's high. It's more than 5. I'll take a big market. I'll take that market, not expect the whole market. And the bottom line is, I know that if we flatline things with our safety profile, we're not going to get no's from UK, EU, and Australia. They're going to say this drug is going to be valuable to patients and to our healthcare systems, because it'll keep people from getting worse and keep them out of long-term care.
No, it sounds.
And Eric, I've
yeah.
I've had the opportunity to talk to RJ a few times. I certainly listened to all the calls and spoke to a lot of the staff. And you never hear if we do phase 3. It's always when we do it phase 3. These guys feel like they're holding pocket aces. They really do, and it's unusual. I mean, there are certainly some biotech companies out there that play fast and loose. When you have a company like this with serious scientists involved, usually they use the term if, not when. So it certainly gives me some confidence that
the conviction
they've got a good hand.
Yeah. RJ, I think this has been great, and John, thank you for teeing it up for us. And this definitely sounds rare. I mean, it sounds like a very great investment opportunity and a good time to be doing work on it. And I hope this helps everyone. But then also, I mean, such an amazing thing when it does work out, and what it will do for people that John was sharing with us the little audio clip of the story of the physics teacher, and I don't know, it was just very cool. And hopefully there'll be more stories like that in the future, thanks to this and thanks to your hard work.
Maybe
one of the things that I've been touched at as I've been involved with this, when you were talking about transplant drugs, that was a very small part of the population. When you get into oncology, it kind of resonates because there's a lot more people where cancer has touched their family. But I can tell you, every meeting we have, the investor has either a family member, a friend, or a relative that has really been touched directly by Alzheimer's. It's a bad disease. It's a painful disease. It's actually less painful to the patient than it is to the caregivers. I mean, the caregivers watch this previously fantastic person become a mere husk of the previous cells. But the bottom line is, people really kind of, I think people are rooting for us, and we hope to make a difference at the bedside, and I'm confident we will.
Yeah, I think everyone's rooting for you. I think that's exactly a good way of saying it. RJ, John, thanks very much.
Sure. Thanks, Eric. Appreciate it.
Thanks, guys. Cheers.
Bye.